All right, so this is the exam number 3 review. This will be a review on chapters 11, chapter 12, chapter 14. So it's a little lengthy. This is an optional video. There's nothing new covered here. It's just homework problems being solved for chapters 11, 12, and 14. So chapter 11 is first. Chapter 11 covers alkanes, alkenes, alkynes, cycloalkanes, cis-trans isomers, addition reactions of alkenes, right? Halogenation, hydrogenation, and hydration reactions. And also at the end, we talk about aromatic compounds. All right, so the very first problem in chapter 11 that I'm going to do for you is problem number 10 from your homework. Draw a structure for each. So the first one is propane, second one hexane. These are all alkanes. So first thing I do is I just kind of draw a skeleton structure, a real rough sketch. Now that is not the final sketch, the final structure. The final structure is in boxes. And so I've drawn either a condensed structure or I've drawn the, your book calls it the line angle structure. These are also called Kekuli structures. But either one is correct, and unless I identify on the exam which one I want, you can use either. It's important to notice here that with alkanes, the end caps are CH3s, and everything in between is a CH2. Now that will change if you have a branch, but these are all straight chain alkanes, no branches. And in D with the cyclohexane, I generally just stick to a line angle format. All right, next problem in chapter 11 is question number 11 and 12. They have the same instructions. So it says in each pair below, we want to know, are these identical compounds or are these structural isomers? Okay, so structural isomers, just so you know, they have the same formula, like C6H14, C5H12. They have the same formulas, but different connections of atoms. They're different compounds. They're isomers. So 11b, the first structure I'm drawing here, CH3, it's got one branch on it, doesn't it? It's got that little methyl branch sticking up. The next compound is written as such. Now those are not branches. You see on the second compound, I can drag and write that full strand, that full string of carbons linked directly, okay? Remember, carbon-carbon single bonds are, you can swivel them around, all right, like a string, because they're not rigid like double bonds and triple bonds. So the second one here, 11C, I have 5 carbons that I was able to circle, and over here I could only draw 4 carbons with 2 branches. So these are isomers as well. These are not the same compound. 12B, so let me get these 2 compounds written out for you here, and then we'll have a look. The best way to do this is to draw a kind of snake or draw connections for the longest uninterrupted chain of carbons. All right, so if I do that in the first one, I get a 5 carbons. Second one, I get 5 carbons. But the branches are on different carbons. So these are very close, but they are still isomers because the branching isn't 2 and 3 on the second one. The branches are 2 and 3 and 2 and 4. That's different. Now 12C, if I draw the connections here and I have a look, these are actually identical compounds. Identical compounds have just been moved on the page. They're the same. Okay, so the next problems are 13 and 14 from chapter 11. It says, name the following compounds. So if they want the name, then what we're going to receive are the structures, okay? And these structures can either be line angle formula or they can be condensed formula. All right. So 13B, 13C, let's get these drawn out and then we'll try them. So for 13B, I'm putting dots on what I think is the longest uninterrupted chain, and then I'm circling the branches. So it's 2-chloro, 3-methyl, pentane. Notice the C in chloro comes before the M in methyl. For 13C, I notice that my longest chain is 6 carbons. I want to keep the branching as low as possible, so I put carbon 2 for the 2-methyl groups. E comes before M. That's why I'm double underlining there. 4-ethyl, 2,2-dimethylhexane. Okay? 14B, I've got a bromine branch and I've got a methyl branch. So this is going to be 2-bromo, 4-methyl heptane. Heptane is a 7-carbon chain. And the B came before the M, right? 14C, they're giving me the condensed structure. I need to be careful with this one, make sure I find the longest chain. So there's a little asterisk by 14C because I've changed it from the actual problem. Now look at the longest chain. It's not what we physically see with our eyes. It's not the linear one in this case. It has a hitch up, and that gives me a 7-carbon chain. And I'm sort of circling, half circling, the 2-ethyl branches. So numbering the carbons in the direction that makes the branching the smallest, I have 3,4-diethyl heptane. So be careful on ones like that where the straight chain you see isn't necessarily the longest chain. All right, next page here. This is chapter 11, number 16 and number 18 together. Draw structures for the following. If they want me to draw the structures, then chances are they have to give me the names, right? It goes either way. Whichever one they want to ask you, they have to give you the other one. So if they want the structures, they're going to give me the names. So let me get the names drawn out here for 16A. Pentane. So let's just draw a bare bones pentane with a bare bones ethyl branch. Now I can't put a box around that and call it finished. You have to put your H's in. So CH3, CH2, CH with an ethyl group, and then CH2, CH3. Now if I were to do that in the line angle formula, this would be my answer. So either one of these is acceptable. 16D, draw a 3-carbon propane with a 2-bromo branch, and I end up with a CH3, CH, CH3 with a branch on the middle CH there. I've also drawn it in line angle format. Cyclohexane, in this class we always want to use the line angles for cyclos, and there are 2 ways to draw my ethyl branch there. Okay? For 18B, the name of this guy is methyl cyclopropane. So cyclopropane just looks like a triangle. It's just 3-carbon cycle. And then the methyl I can put on any carbon I'd like. Now I've drawn it out here just to show you, but really the preferred one is the line angle. Either one is correct. All right, number 26 in chapter 11 wants us to name the following hydrocarbons. So hydrocarbons are either alkanes, alkenes, alkynes, or aromatic rings, aromatic compounds. Sometimes they have branches, and those branches no longer make them hydrocarbons. Hydrocarbons only contain carbons and hydrogens. So I'm drawing them out here. You can see that the first one is an alkene, double bond. B is an alkyne with a triple bond. And C is an alkene with a double bond. So the alkene always gets the lowest branch number. For A, it will be 1-butene, not 3-butene. For B, the numbering must begin from the left, closest to the alkyne end. That makes it a 6-methyl, okay, not a 2-methyl. So it's 6-methyl 2-heptine. Last one, cyclopentene. Please pay attention to where I put dashes and commas when I'm naming my compounds. Chapter 11, number 28 says, draw structures for the following compounds. That means they're going to give me the name, right? So for 28B, 1-bromo, see where the dashes are all placed? 1-bromo, 3-hexyne. So I would start by drawing the hexyne. And D, 2-methyl 2-hexene, I'd start by drawing the 2-hexene. So 3-hexyne, I've drawn it out. 1-bromo, I'm just dashing in all my H's. Notice there's no H's on the triple bond carbons. And now I have to write it out properly by putting my H's in. I do so, I put a box around it. If you're going to draw the line angle formula, please be aware that triple bond carbons are linear. Okay, they go out. So you see how it looks funny there for the line angle formula? It's always going to look funny for a triple bond when you draw the line angle formula. 2-methyl 2-hexene, draw the bare bones. I put my little C off of carbon 2, that's my methyl branch. And then I begin to place all my hydrogens where appropriate. Careful with the double bond carbons. One of those gets no H's, the other one only gets one. If I draw this out in the line angle formula, I arrive at the one you see in the box below. This takes tons of practice, as you know. This is why I'm going over this 40-minute review. Okay. So number 32 in chapter 11, draw structures for each of the following. A, cis 1,2-difluoroethene. Cis-trans isomers, for us, cis-trans isomers are with alkenes. Okay, so these are both alkenes. Ethene is just a C double bond C. 2-pentene. See how I've drawn both of them by putting carbon-carbon double bonds and then spoking out my branches? Cis is the same side. Cis, same. So both F's go up. You could have made them both go down. And then trans is like transcontinental, across or opposite. So I draw those guys opposite. In other words, the H's are opposite for trans. The H's are together for cis. All right, so make sure you know how to do cis-trans isomers. Happens with alkenes. Okay. 34, draw structures of the product or products of each reaction. I'll always be specific for you guys if I want one product or two. Okay. So this is an alkene reacting with water. H plus means it's in the presence of acid. B, we have another alkene, but this one's reacting with H2. So A is a hydration. B is a hydrogenation. Hydration, adding water. Remember, the H part of water, if you're thinking of adding water, it's like adding the HOH. So the CH2 off of the alkene, you put the H where most of his buddies already are. So the OH would exclusively go on that carbon number 2, and the H goes on the end carbon. For hydrogenation, it's simple. As far as the product is concerned, you just remove the double bond because we're adding H's across it. C is just like B. It's a hydrogenation. That's just going to be, instead of a cyclohexene, it'll be a cyclohexane in C. Hydrogenations, you just basically, from a visual standpoint, you just remove the alkene. But what's really happening is you're making those two carbons saturated. You're adding more H's. For D, I've changed it up. This is a halogenation. Halogenation is when you add Cl2 or Br2, and each Cl and Br goes to where the double bond carbons are. 36 was not assigned, but I think it's important to go over it. So 36 says, name the following aromatic compounds. So to draw an aromatic compound, for us in this class, it's a benzene ring. There are two ways for us to draw benzene rings. You can draw the circle in the middle, or you can draw alternating double and single bonds. And I've drawn both here. So A, B, and C. For A, I'm circling the parent. The parent here is not benzene, it's toluene. In B, the parent is not benzene, it's phenol. In C, the parent is indeed benzene. Okay, so this would be 2-bromo-toluene. Now the 2 position is also ortho. So you could also put ortho-bromo-toluene. That wasn't in your book, but that was in your notes. So it's important to know that. Ortho, meta, para stuff. So for B, it's 3,5-dichlorophenol. And for C, it's 1, 2, 3, 4. So then you have to you want to number it with where you get the branches being the lowest. So you have to do the chlorines 1 and 2. B comes before C. So for C, it's 4-bromo, 1,2-dichlorobenzene. Pay attention to where I put the commas and the dashes. Number 38 in chapter 11 still. What's the structure of 1,2,4-trichlorobenzene? So go to the end of it, you see benzene, draw benzene, and then you can arbitrarily pick your 1, 2, and 4 spots and put chloro in each. Okay? So that's it for chapter 11. Chapter 12 talks about alcohols, thiols, ethers, aldehydes, and ketones. We are not going to talk about thiols. Those are the sulfur compounds. We're focusing on oxygen compounds, alcohols, aldehydes, ketones preferentially, but there is some in there on ethers. Number 2 in chapter 12 says name the following. So let's get these all written out. We got A, that's going to be a phenol parent, right? A phenol is not an alcohol, okay? OH cannot be on a benzene ring directly and be an alcohol. B is indeed an alcohol. C is indeed an alcohol. And it looks like D is also an alcohol. A is not an alcohol. It's a phenol, P-H-E-N-O-L. That's the parent. Branches on 3, so it's 3-ethyl phenol. But if you remember, 1,3 substitution on the benzene is also meta. So it could also be called meta-ethyl phenol. B, we number from the end nearest the OH. This is going to make the branch 2, 2-methyl, 1-butanol. I have to put the 1 in there because I have to tell you where the OH is attached. It's attached to carbon 1. For C, obviously I begin my numbering from the far right where the O is. That makes my branches 2, 3. So 2, 3 dimethyl, 1 pentanol. The 1 is because I have to tell you where the OH is. In D, there's many ways I could have had a OH on D. It happens to be on carbon 3, so I call it 3-hexanol. All right, chapter 12, number 4. Draw structures for the following. Ethyl alcohol, that's a common name. And B, 3-methyl, 1-butanol. That's an IUPAC name. So ethyl alcohol, its IUPAC name is ethanol. It's 2 carbons. Put the OH on either carbon, it doesn't matter. You end up with CH3, CH2OH, or the line angle structure below it. 3-methyl, 1-butanol. To draw 1-butanol first, you put the OH on the end. And then if I put the OH on the end and number that carbon 1, that tells me where carbon 3 is. I can put my methyl group or my CH3 group there appropriately. If you want to do the line angle structure, that's quite all right. This is how it would look. So make sure you know how to go between line angle structure and condensed structures. Number 6 for chapter 12. Name the following. So we're going to get these all written out. We have to give you the structures if we want you to name it. So I'm going to blow letter A out and stretch it out a little bit. You see how I've just taken one condensed structure and made it a little bit less condensed? So the O there, a C-O-C bond, is an ether, assuming those carbons are saturated. So you got ethyl, propyl, ether. Now I didn't name it because it's left to right. I named it ethyl propyl ether because E comes before P. Just in case you want to know what the line angle would look like for that line angle structure, I've drawn it for you. All right, so that's an ether. You probably will see 1 or 2 of those, not many on the exam. Number 10, classify each alcohol as primary, secondary, or tertiary. So a primary alcohol, the carbon that the OH is attached to one other carbon. Secondary would be attached to 2 other carbons. So let's practice this. Take a close look at C. C is an alcohol because that OH is not directly attached to benzene. It's not a phenol. C is indeed an alcohol. So I'm putting big dots on the carbon I need to focus on because it's attached to the OH. So in A, the carbon is attached to 2 other carbons, secondary. In B, the carbon's attached to 1 other carbon, that's primary. C, primary. And D, the carbon I've highlighted, is attached to 3 other carbons, so it's tertiary. All right, number 16, aldehyde or ketone. Very simple way to do this. Aldehyde are on the end. Aldehyde, end. So if they're on the end, the double bond O is on the very end of the molecule, and it has a little H hanging off of it. That's what aldehydes are. So A and B are aldehydes. C and D are ketones. Why? Well, because the C double bond O's are in the middle for C and D, and the C double bond O's are on the end with a little endpoint H attached for the aldehydes. Okay? See how that's done? So aldehydes are on the end, ketones are in the middle. All right? So that's a very simple way to remember. Now that can get a little more convoluted when we introduce carboxylic acids, esters, and amides. So just be aware of that. Number 20, chapter 12. Name the following compounds. All right, so I got a bunch of CC's and CH's. On the very end, I have a carbon double bond O with an H. That's going to be an aldehyde. B, this is going to be a ketone. D, ketone. Now I have to name them, so the C double bond O gets preference. It's carbon 1. This is 3-methyl pentanal. 5 carbons, pentanal. Aldehydes have the ending Al. Ketones have the ending ONE. So B, no branches or anything, it's just 2-pentanone. You have to let the reader know where the ketone is in B, 2-pentanone. For D, cyclopentanone. To make it 1 cyclopentanone would be redundant, because wherever the ketone is, it would be carbon 1. All right, number 21 and 22 wants us to draw structures, so they're going to give us the names. 21B has little asterisks. I've changed it up. But 3-hexanone. Hex is 6. Let's draw 6 carbons. Put the double bond 0 on 3, because 3-hexanone. And then we make a branch, a Cl branch on carbon 4. Do that, and you come up with the following structure. I've drawn a line angle structure first. So let me do the condensed structure, which some of you like. These are 2 correct structures for 4-chloro-3-hexanone. 21C, butyl methyl ketone. This is a common name. So draw the butyl on the left, the methyl on the right, and then you put your ketone in there, all right? Ketone separates the two. Now, you could have put the butyl and the methyl on either side. It doesn't really matter. But the structure is drawn in both formats. And by the way, the IUPAC name for this would be 2-hexanone. Okay? 6 carbons with the ketone on carbon 2. 2-hexanone. All right, next page here. We're still on chapter 12, the middle chapter. So the 28 from chapter 12 says, draw the product of each dehydration reaction of the alcohol. So this is some specific instructions. We're going to dehydrate an alcohol. Dehydration of alcohols always gives you the alkene. Okay? So CH3, CH2OH in the presence of hydrogen, ion, and heat. This is acidic conditions where it's hot. Triangle is the same thing as heat. I'm just drawing it different ways. So dehydration means you're removing water, right? That's why you should see water as a byproduct of each of these reactions, and we do. So we have to draw what's in the box. You just find the OH carbon, and then you put a double bond between it and the neighboring carbons. So I'm putting dots on some of the neighboring carbons here to show you how I am dehydrating. Remember, you're not just removing the OH, you're moving a hydrogen from the neighboring carbon. If you remove an OH and an H, you get a double bond right there. Okay. Now in C, I could have also taken the other H on the bottom next door area. It gives me the same product. You could just spin it. Okay. So when you dehydrate alcohols, you get alkenes. All right. Questions 30, 32, and 34 from chapter 12 all have basically same instructions. Predict the product of each reaction. So I've selected some. 30A, I notice that this is a primary alcohol. It's got that bracket O, which means I'm going to oxidize it. So primary alcohols oxidize to the corresponding aldehyde. That's if we have only 1 round of oxidizing agent, 1 round of bracket O. So you see how I converted my primary alcohol to the corresponding aldehyde? If I had had 2 rounds of oxygen there, I could have oxidized the aldehyde further to a carboxylic acid. And we'll see that with primary alcohols in just a second. Now, B is a tertiary alcohol. You notice the carbons attached to 3 other carbons. These guys do not undergo oxidation. Tertiary alcohols do not undergo oxidation. This would be NR, no reaction. So we saw the primary alcohol, that one worked. In 30D, a secondary alcohol gets converted to a ketone, and it stops right there. You cannot oxidize a ketone any further. Primary alcohols can get oxidized to aldehydes and then further to carboxylic acids, which is what we're going to see here. So here, this is what? 1, 2, 3, 4, 5. This is 1-pentanol. It gets converted to pentanal. Now, I've got two oxidizers there, don't I? So I have to keep going. This aldehyde is just an intermediate. The reaction doesn't stop. We go all the way to the 5 carbon pentanoic acid. So I went from 1 pentanol to pentanal all the way to pentanoic acid. Now 32C is yet another primary alcohol, and this time I'm writing the 2 in front of the oxidizing agent, O, just to show you a different way it could be written. But I'm going to go all the way from the primary alcohol 1-butanol to the intermediate aldehyde, and then it keeps going all the way to the carboxylic acid. Okay, so 1-butanol went to butanal, went to butanoic acid. Be aware of that. That's something I do like to put on the exams. Chapter 12, 34A. This is a ketone. See the C double bond O surrounded by 2 saturated carbons? Ketones and plus H2, this is a reduction. So you find the C double bond O, and then you put an H on that O, and H on the carbon below the O. So basically it's like you're adding H2 across that C double bond O double bond. Ketone gets reduced to a secondary alcohol. If you're adding hydrogen, it's reduction. If you're adding oxygen, it's oxidation. Now, these nickel catalysts could also be platinum catalysts. It's an inert metal that is not involved. It's a catalyst. So ketone gets reduced to secondary alcohol. In 34B, we see an aldehyde getting reduced to a primary alcohol. Just depends on where the C double bond O functional group is located in the starting material. All right, so that's chapters 11 and chapters 12. Here comes chapter 14. Chapter 14 is carboxylic acids, esters, amines, and amides. All right. Number 4 from chapter 14 wants us to name the following compounds. If it wants us to name the compounds, they're going to give us the structure. So A, I only have 1 carbon. If you only have 1 carbon in A, that's some sort of methane derivative, right? So the IUPAC name for A would be methanoic acid. Now, you are required to remember that methanoic acid has a common name, and that's formic acid. In B, I do see the C double bond O OH. That's a carboxylic acid, 5 carbons long. This is 2-bromo-pentanoic acid. In D, I see the carboxylic acid. Carboxylic acids are always on the end as well, just like aldehydes. This would be 3,3-dimethyl butanoic acid. So carboxylic acids are always found on the last carbon, just like aldehydes are. That's why we don't need to preface where it's located in the molecule. 6, draw structures. So that means they're going to give me the names. And B has a little asterisk by it. So 6B from chapter 14. I've changed it up a little bit. This is 2,2-dichloropropanoic acid. C, 3-ethyl benzoic acid. So draw the parent first. Propanoic is 3 carbons. Draw the carboxylic acid. And you know you have to put 2 chloros on 2. So it's going to have the structure I'm putting in the box right here. Or if I draw the line angle structure, you get something in the box to the right. All right, for C, draw benzoic acid first, 6-membered ring, alternating double and single bonds, or the little circle. And then you put your benzoic acid, you have to finish it off with a thing to double bond OOH, then find carbon 3. All right, this could have also been called meta-ethyl benzoic acid. D, hexanoic acid, that's just 6 carbons. Boom, 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 boom. All carbons are there. C double bond O, OH. Hexanoic acid. Remember, carboxylic acid functional group is always on the end of the molecule or end of the chain, just like aldehydes are. All right, chapter 14, number 12B. 2-methyl-butanoic acid plus KOH yields what? Well, this is a neutralization reaction. It's the only reaction you have to know for carboxylic acids. Certainly, I have to draw out the structure in order to predict the product. So I've done that. Down below, you see the KOH. What happens is the hydrogen that I've made the arrow to is going to get plucked off leaving us a little minus charge, which will match up with the group 1 cation K plus water. So we've neutralized this. We've taken an acid plus a KOH, excuse me, which is a base. We made that neutral salt. That salt is called a carboxylate salt. And that's in your notes. Chapter 14, number 16 and 18. Predict the products. So these are going to be reactions. If they ask for me to predict the products, they're going to give me reactions. Unfortunately, in 16a, they're giving me word formulas. So I'm going to have to convert those to structures. So anytime I have a carboxylic acid plus an alcohol, I get an ester. Okay, this is an esterification reaction. One of the two reactions you have to know for esters, esterification reaction. You take the carboxylic acid and you literally take the part of the alcohol and attach it where the hydrogen used to be on the carboxylic acid. Okay, look closely at all these. They're all going to be very similar. Okay, 16b, propionic acid, that's in quotes because it's a common name. IUPAC name for us is propanoic acid, which is just 3 carbons, and the oic acid is a C double bond O, OH on the end. Now imagine dropping the hydrogen from that OH right there and putting the methanol's CH3 in its place. That gives you the ester functional group on the right in the box. Okay. 18b, this is benzoic acid plus an alcohol. 1, 2, 3, 4 happens to be 1-butanol. And notice that the benzoic acid, if you drop the hydrogen and just put in all of the carbon-carbon bonds that were a part of the alcohol, you get your answer. Okay, so all of these guys are called esterification reactions. The only other ester reaction you have to know is the opposite of this. It's called ester hydrolysis. All right. So 20 says the following. Name these compounds. So A, you see how we have an O in the middle. Now that was almost an ether, wasn't it? But then you see the C double bond O. This is an ester. B is also an ester. These are esters. So circle the guy hanging off of the oxygen, which I did first. So the first one, that's an ethyl group. Then we have 1, 2, 3, 4, ethyl butanoate. See the circled area for B? That's a methyl group. You name that first. And then the remaining 1, 2, 3, 4, 5, 6, this is methyl hexanoate. All right? Now, be careful. What if the oxygen were written on the left of the ester? Okay, so you have to be very careful on how that gets done. C, once again, the ester 0, the ester oxygen's on the right. So I look at all these guys on the right. There's 4. That's a butyl. Butyl is my first word. 1, 2, 3 is the remaining other half. This is butyl propanoate. All right? Careful. The oxygen can sometimes be written on the other side, on the left. So number 28 says, predict the products of each hydrolysis reaction below. So this is going to be the opposite of the esterifications we saw on the last page. This is going to be hydrolysis. We're not making esters here. We're breaking esters up into, you guessed it, alcohol and carboxylic acid. So notice you have to add water to this. That should, if you ever see ester plus water, this is hydrolysis. So you break it up. This is the exact opposite of esterification. So now we're going to have our carboxylic acid product plus the remaining alcohol product. And I've drawn a little dashed line there where it actually breaks up. Okay, this is called ester hydrolysis. That was 28A. 28D, this is from chapter 14. I've got this crazy looking ester, but if I see plus water in the presence of acid, H plus, and heat, the triangle means heat, I just have to draw a little cleavage dashed line, split this ester up into a carboxylic acid and the proper alcohol. All right. Question number 30 from chapter 14 says, name the following. If they want us to name something, they're going to have to give us the structure, whether it's a condensed structure or a line angle structure. So in these, I'm not seeing any C double bond O's anymore. These are amines, A-M-I-N-E. Okay, this is called methyl ethylamine. Now, It would be acceptable for me if you called this methylamine, just because my notes are a little bit different than your book. But in any case, you see we have a nitrogen. This is an amino group, amine, so you got a methyl, ethylamine. B, 1, 2, 3, 4, 4 carbons with an NH2 on the end. This is butylamine. C, I see a nitrogen surrounded by 3 ethyls. That's triethylamine. Question number 32 from chapter 14 wants us to draw structures. All right, well, they must be giving us the names then. A, diethylamine. B, 4-chloroaniline. So my eyes first see this in A, amine. B, aniline. C, aniline. Draw the parent first. So the amine, I see diethyl. I'm going to be putting 2 ethyl groups on a nitrogen. Remember, nitrogen only has 1 lone pair, which is why that hydrogen has to be attached. And then I've also drawn the line angle structure for you as well. Aniline is a benzene ring with an NH2 directly attached. Okay, that's aniline. And then I put a 4-chloro on the 4 position. So that is the structure for 4-chloroaniline. In your notes, you learned aniline is a benzene ring with an NH2 directly attached. Okay, so this is N,N-diethylaniline, which means I have to get rid of those hydrogens and put my ethyls in its place. So this is a disubstituted aniline molecule. All right, question number 34 wants to know, just like alcohols, right? Amines can be primary, secondary, or tertiary. So for A, probably a B and a C here, I'm going to give you some amines. They're not asked to name them, but we could. And we just want to know, hey, is this primary, secondary, or tertiary? So 34A, if I look at the nitrogen, that nitrogen is attached to how many carbons? It's attached to 1 carbon. This is a primary amine. Find the nitrogen in B. How many carbons is it attached to? 3, tertiary amine. 34D, the nitrogen is attached to only 2 carbons. This is a secondary amine. The naming is a little different than alcohols. Be very careful, okay? Not the naming, but the classification, how you classify primary, secondary, and tertiary is a little bit different for amines and alcohols. Number 42, name the following. Okay, I still see the NH2 group like I've been seeing in the past, but now it's attached to a carbon that's a C double bond O. These are no longer amines, these are amides. Okay, so this is 1, 2, 3, 4, 5. This is pentanamide. In C, I've changed it up a little bit. But this is 5-methyl hexanamide. Amides are on the very end of the chain. Amides, carboxylic acids, aldehydes are all on that final carbon. Okay. 44 in chapter 14. Draw structures for the following. Okay, remember just to skeletize it out. Just do C-C-C, put the N in. Bare bones it at first, like I did. See? 7 carbons, and then amide is on the end. Blah, 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 everything is H's. Now write it in correctly. CH3, CH2, 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 C double bond O, NH2. 7 carbons, amide on the end. This is heptanamide, and I've drawn the structure 2 different ways for you, okay? D, N-ethyl. What does that capital N mean? That means the ethyl is attached to the nitrogen. N-ethyl means the ethyl is attached to the nitrogen. So propanamide is only 3 carbons. I can draw that in. And then I clean this up and write a box around my completed structure. If I was asked to do the line angle structure, it would look like such. Now, rather than parentheses, CH2, CH3, you could have also put a little direct bond there, all right? So this is a pretty good review. One thing I do want to mention is there's a lot of stuff that is not covered here because it's just information in the notes. So when you wrote the lecture notes, things like solubility, polarity, boiling point, melting point, like for example, carboxylic acids that are 5 carbons and less, they're soluble in water. Things like that, those are like the beginning of the exam, multiple choice questions, fill-in questions. But if you know this video, you're going to know most of the exam, okay? Not all of it, but most of it. So definitely go through your notes and look for bullet points that you think are multiple choice type stuff, fill-in type stuff, stuff that makes me check on whether or not you also watched the videos and took notes. All right, so your exam is coming up soon, and hopefully this helps.